Good evening. Today we will try to explain the math side of pendulum experiment. Let me start from the question. The question, we have two kinds of questions. The first one will be determine the acceleration of a free fall ball by using simple pendulum. According to the table below, to the column below, will be the length of the pendulum, the first time, the second try to calculate the time period. And after that, we will complete the others. Here, by using the red pen, they are my solutions. We will try to follow me to can plot the necessary curve, and after that, I will learn you how you can calculate the acceleration. And the second kind of the question will be proof. Prove the acceleration equal what meter divided on second squared according to free fall ball by using simple pendulum according to the column below. Here it's important, this number, the time oscillations. Here it's 10, it's written as 10 oscillations. It's important, maybe can be 5, 15, 20, I didn't decide yet. Let me add first take the T average from all of the T1 and 2 to be plus between them and divided on 2. I will have these numbers. After that, according to this number here, it's 10. That's mean these numbers, first one and second one, is to 10 oscillations. But I need to 1 oscillations. We will follow this way to make a precision, to make a accuracy to our result, okay? To minimize the mistakes as possible. After that, to take to 1 oscillations, just we will divide all of these results divided on 10 to have these results. And after that, I will put square above all of these results to can reach T square result, because it's important. The time period oscillation square is important because we'll be at y-axis, and the length of the pendulum will be at x-axis. I will explain that at the plots below. But here it's important. We will have results like that. It's difficult to deal with it to can plot your curve. By that, we can use the rounding number. It's not a problem to say 0.789. It's approximately 0.8. That will give you opportunity to can plot better curve with less mistake. Here, let me minimize my screen. And let me keep going. Here at x-axis, I'm talking now about the length of pendulum. I said every 20 centimeters of the pendulum length here, my pendulum, my string is weightless according to the iron ball. I have 20 centimeters, 40, 60, 80 according to 1 meter, 200 centimeters, okay? Here it's point A is the raised point, is the main point. When I displaced it to B, reach B and take it go, leave it to go, from B will go to C according to the same angle, 10 degrees from left and right, and come back to B. That's mean it's a one oscillation. And the time, the necessary time to make this iron ball go from B and come back to the same point, it's named as a time period, T small, okay? Here, like I said before, every 20 centimeters from the length, pendulum length equal to centimeter in my x-axis. That's been 40, 60 according to 100 centimeters to the pendulum length. And let me go to y-axis here. Every half second square equal to centimeters. That's mean 20 millimeter. According to that, I can say every dot 1 second square equal 4 millimeter. That will give me a specifically result. When I will try to plot my curve, when I try to place these positions in y-axis correctly. 0.5, 0.8, 1.5, 2.3, 3.1, and 3.8, according to this statement, according to this equation. When someone asks me why t squared, not yt, because according to the equation number one, t equal 2 pi, and under this root, L, length of pendulum divided on acceleration, you can disappear this root. We will say, let's take square to these two sides from this equation to be t squared equal 4 pi squared multiple length divided on acceleration. And according to the inside of this red pen, slope equal 4 pi squared divided on acceleration. This equation is important. It explains to us the relation between slope and acceleration and why this equation is very important. By that, I can calculate the slope from the curve. By that, I will have just unknown one value in this equation, and by that means I can calculate it by saying acceleration equal 4 pi squared divided on slope.